Now we're going to carry out the Fourier series of a square wave, and the square wave is defined along the period from -2 to 0. It's going to be given as -1, and from 0 to 2 it's going to be given as 1, and it'll carry out that general period over and over and over. So let's find a sub 0 first. So a sub naught is equal to 1 over L, integral from -2 to 2 of f of t dt. And again, we don't really even have to carry out this integral because we know integral from across the entire period of f of t, well, that's just going to be 0 area equal to 0. Now let's do a sub n. A sub n is equal to 1/2 integral from -2 to 0, because we can't integrate across the entire thing easily. We have to split it up into two integrals. So that's from -2 to 0 of -1 cosine n pi t over L, or over 2 because L is equal to 2, dt plus 1/2 integral from 0 to 2 of +1 cosine n pi t over 2 dt. And again, we're going to see this is equal to 0 if we carry this out. Now we're going to go for b sub n. B sub n is equal to 1/2 integral from -2 to 0 of -1 sine n pi t over 2 dt plus 1/2 integral from 0 to 2 of +1 sine n pi t over 2 dt. And if we carry out this integral, we'll find b sub n is equal to 1/2 of this evaluated at, well, 2 over n pi cosine n pi t over 2 evaluated from -2 to 0 plus 1/2 -2 over n pi cosine n pi t over 2, well, evaluated from 0 to 2. And so let's think to ourselves, when we're plugging these boundary conditions, what's cosine of n pi? Well, cosine of pi is -1. Cosine of 2 pi is 1. Cosine of 3 pi is -1. And since we know that n pi is only going to have integers values of n because this is a series, we can just say cosine of n pi is -1 to the n. And so that's going to leave us with 2 over n pi times 1 minus -1 to the n, and same for this side. And so once we evaluate that, we're going to find that it eventually equates to 2 over n pi times 1 minus -1 to the n, which is equal to the piecewise function 4 over n pi if n is odd, and 0 if n is even. I should probably write the n further left, yeah. And so we have all of our coefficients, so let's just plug it into the equation. So our function is approximated by a series for all odd integers 1 over n sine n pi t over 2 times 4 over pi. And if you carry out this Fourier series to maybe 5 terms or 6 terms, you'll see that it gets closer and closer and closer to approximating this periodic function.